Have you ever had a moment, on a dark night, with the sky fully starred, and asked yourself, how did all this begin, where did the universe come from? And immediately afterwards you thought of several hypotheses, or you couldn't think of anything at all. Then get ready to have a definite answer right here and now. Today we will explore one of mankind's greatest enigmas, the origin of the universe. Get ready for a fascinating journey through the cosmos. Welcome to Astro Geeks, your new channel of astronomical trivia and news. And to support us, don't forget to subscribe and hit the like button to strengthen our community. So let's go to the video. The Big Bang was an extraordinary event that marked the beginning of everything we know in the universe. Imagine a huge cosmic explosion where all matter, energy, and space-time were created in a single instant. It is as if the universe started from an extremely hot and dense point, smaller than the tip of a pin. Impressive, isn't it? This was the explosion that started it all. At that moment a rapid and violent expansion took place, where space-time expanded in all directions. It is as if the universe was inflating, becoming larger and smaller. This expansion allowed elementary particles to form and interact, eventually giving rise to the stars, galaxies, and all the diversity we see in the cosmos today. This theory, which is widely accepted by scientists, gives us an interesting insight into the origin of the universe. However, there are still many mysteries to be unraveled. And we will explore further to understand about the formation of galaxies, the role of dark energy, and the fate of the universe. In the first instant after the Big Bang, something extremely peculiar happened. The universe went through a phase of high density and temperature, where all matter and energy was concentrated in one tiny point. We call this state the singularity. This singularity is a fascinating concept, because it represents a region of space-time where the laws of physics as we know them do not exist. It is a point of infinite density and temperature where the rules of our universe simply do not apply. It is difficult to imagine, but it is from this singular state that space-time began to expand. As the expansion began, matter and energy spread out through space in a process that is still ongoing. It was at this point that space-time itself began to form. As the universe expanded, subatomic particles, such as protons and electrons, appeared and eventually clumped together to form atoms. And over time, these atoms clumped together into clouds of gas and dust, which gave rise to the first stars and galaxies. Thus, from the initial singularity, the universe began to evolve and develop in all its vastness and complexity. Do you know the theories that try to explain this cosmic event? One of the most, if not the most famous among them, is the cosmic inflation theory. According to this theory, right after the Big Bang there was an extremely rapid and exponential expansion phase of spacetime. Imagine the universe expanding at an accelerated rate, as if it were inflated. We can imagine a cosmic balloon. But how can we know if this theory is true? Here comes in an important piece of observational evidence, the cosmic microwave background radiation. This radiation is like an echo of the Big Bang, being part of the first moments of the universe. It is a kind of cosmic fossil that was discovered by scientists in 1965. This radiation permeates all space and is uniform in all directions. But, most interestingly, this radiation is incredibly uniform in temperature, varying only in small variations of millionths of a degree. This uniformity is consistent with the idea that the universe went through a period of rapid expansion, cosmic inflation. In addition, detailed observations of the cosmic microwave background radiation made by satellites and telescopes have confirmed many predictions of the cosmic inflation theory. This strengthens the idea that there was a rapid growth of the universe early in its history. The cosmic inflation theory helps us understand how the universe evolved from its birth to what we see today. It is an important piece of the puzzle of the origin and evolution of the cosmos. After the Big Bang, particles and gases clumped together in larger and larger regions, forming the first structures in the universe. It is as if small cosmic blocks came together to create something larger and more complex. These clusters of matter and energy formed cosmic filaments, which are like great webs that interconnect galaxies and star clusters throughout the universe. These filaments play a crucial role in forming the cosmic structures that we see today. As galaxies formed, within them emerged stars, veritable factories of light and energy. It is as if tiny star seeds were ignited and began to shine brightly. Stars are born in molecular clouds, which are large clusters of gas and dust in space. We can call these clouds true stellar nurseries, where gravity begins to act, compressing the material and giving birth to new stars. At the heart of the stars, an amazing reaction called nuclear fusion takes place. It turns hydrogen into helium, releasing enormous amounts of light energy. This fusion is like a veritable stellar forge, where heavier elements are also created and spread throughout the universe. As the universe expands, a mysterious force called dark energy comes into play. This energy fills space and acts as a repulsive force, further accelerating the cosmic expansion. Although we know little about dark energy, it comprises about 70% of the energy content of the universe. Its presence is responsible for driving the expansion and shaping the fate of the cosmos. Dark energy causes an acceleration in the expansion of the universe, counterbalancing the gravitational pull exerted by matter. This cosmic acceleration has major implications for the future of our universe. The future of our universe is a great mystery. But there are two main theories. One suggests an eternal expansion, where the universe will continue to expand indefinitely. The other theory points to a possible collapse in which the universe would return to a compact state. If eternal expansion prevails, the universe will continue to expand further and further, stars will move away from each other, and the formation of new galaxies will decrease. Eventually, starlight will be extinguished and the universe will plunge into a cold, dark age. On the other hand, if collapse occurs, the universe may contract under the action of gravity, culminating in an event called the Big Crunch. This would be the dramatic end, where space and time would merge into a single point. A little scary, don't you think? And so, folks, we come to the end of this journey through the universe and its origin. And you, how do you think the end of our universe will be? Do you agree with any of the theories? Let us know in the comments. And don't forget to subscribe to our channel and leave a like, sharing this knowledge with the world. See you soon with more cosmic explorations. See you there.